Number 33, we are looking for the limit of the greatest integer as x approaches 0.01. So yeah, 0.01 would be right, real close to there.
12, I thought you were supposed to figure it out by substitution, not just drawing a graph.
We could put 1/2 in.
Are you ready?
What's the greatest integer that we are at 1/2? You're following the number line, 0 to 1, there's 1/2. What is the greatest integer that we passed on the number line as we're going to 1/2?
I didn't know that, but, okay.
That's what the greatest integer function is. It's the greatest integer that we have passed.
Okay.
As we get to that number, so we go to 1/2, what's the biggest integer that we passed? 0. Because we haven't got to 1 yet.
Okay, so if it was like, what is it at 2.5, the answer would be 2?
2, yes. And if it was at negative 3.5, the greatest integer would be
-3, or it'd be -2?
-4.
Yeah.
Remember, we're going left to right. So we're going -4, then we're going -3.5. The negative side is a little bit tricky.
Okay.
Any other questions?
Yeah.
No.
Go ahead.
Oh, okay. Can we do, well, I didn't really know if any of these are right, because I can't check them in the back of the book, so can we just do 20 through 28? Because I don't know if any of them
Oh,
are.
you were doing evens?
Yeah, you had us do
Okay.
2 through 28 even.
For the second part of the homework, I realized that when I was like 3/4 of the way through, so it's like.
Alright, so number 2 is 64 feet per second. 4 is 128 feet per second. 6 is c to the 4th minus c to the 3rd plus 1 over c squared plus 9. 8 is 1, 10 is 5, 12 is 0.
Yeah.
14 is square root of 5. 16, there's no limit. 18, the limit is 8.
Wait, what would 18, the limit be 8?
Could we do 8?
Yeah, we'll go look at it in just a second. 20 1/4, 22 is negative 1/4, 24 is 2, 26 is 2, 28 is 4.
Yep, I got it.
Okay,
26 was what?
26 was 2.
Okay, I got that wrong.
Can we do 18 and 22?
Wait, how was
18,
Yeah.
so the limit as x approaches 0.
Oh, no, not 8, sorry. I got that one.
Alright, put 0 in, it's undefined, so we want it to simplify. So that's gonna be 16 plus 8x plus x squared minus 16 over x. 16's cancel out. So we get the limit as x approaches 0. The x's cancel out of 8 plus x. Put 0 in. We get 8.
I did something wrong.
Can we do 22?
Let's just do 20 through 28. Do all those. That's
22. The limit as x approaches 0 of 1 over 2 plus x minus 1/2 over x. Again, put 0 for x, x in the denominator, I can't do that. So when it simplifies, I'm going to add the top. Common denominator is x, 2 times 2 plus x. So what I do here, multiply by 2, so that's 2. What I do here, multiply by 2 plus x. The limit, x approaches 0. That's going to be 2 minus x over 2 times 2 plus x. x. 2's cancel out here, multiply by the reciprocal. X's cancel out, so I get the limit. X approaches 0. Negative 1 over 2 times 2 plus x. Put 0 in for x.
Wait, you said multiply by the reciprocal.
Right.
Oh, it's x, okay. I was
So
thinking
therefore I
those.
get negative 1/4.
Mhm.
Any other questions?
Uh,
How did you get that?
oh, you can go.
Okay, fine. So for number 35, it, I think the answer, like, how would you solve that? For, like, wouldn't it just be
Question.
what doesn't exist? Like, I'm confused.
If you look at the graph, put 0 in, what do you get?
Well, 0 undefined.
Basically undefined, so it's not possible at 0. If you put 1 in, what do you get?
1.
Okay? If you put 1/2 in, what do you get? If you put 0.1 in, what do you get? 0.1 over 0.1?
Yeah, it's 1.
If you put 10 in, what do you get?
1.
Right? So basically we got this and here, that line. If you put negative 1 in, what do you get?
You get 1. Oh no, because the absolute
Negative 1.
value. So it would be 1.
Negative 1. If you put,
Because it was
put 5 in, negative 5 in, what do you get?
negative 5, negative 5. Negative 5. What? No, if you put negative 5 in. Oh, negative 1.
Negative 1. So basically you get this line here. So there's your graph.
Okay.
So now we're looking for the limit as x approaches 0 from the positive side.
So 1.
Correct.
Okay. So I guess you'd have to do that by looking at the graph. Like, oh no, you wouldn't.
What?
I don't know.
You don't necessarily have to use the graph. You could, but you don't have to necessarily use the graph. Because you say if I'm on the positive side, I'm going to have a positive number over a positive number, which is positive 1. Yeah. Any other questions?
Can we do 26, 24, 26, 28? Or, yeah.
Remember 24 is that, as I said, you have the limit as x approaches 0 of sine x over x, that equals 1, correct?
Yeah.
So when we double, or when the period changes, does anything happen to the limit?
No.
No. So that equals 2. Basically what's gonna happen. And because basically we're squeezing it close together.
What is the one, what is that equal 1 again?
But if you graph it on your calculator, you're gonna be able to see that this is going to be, I think something like this.
But isn't that cosine?
No, it's sine x over x. Go ahead and graph it on your calculator, look at
It's
it.
getting smaller.
Correct.
Wait, graph sine x over x.
Mhm.
And sine of 2x over x, you can factor that to be sine of x over x plus sine of x over x, right?
Well, no, 'cause I
No.
have sine of x squared. Right, if it's multiplied.
I guess that works.
You see it?
I think I need to change my window. I
Is
had
that
it,
logarithms?
shows no negatives on the
Correct.
y-axis.
Well, I did that because I got the right answer, but I guess that's the only place that only time.
actually turns into
okay?
Yeah.
So if you did sine two x over x, that hump would be at 2, 3 would be at 3, and 4, that hump just gets bigger and bigger and bigger. Okay?
but wouldn't that be multiplied
Then
function? Wouldn't it
24 and
make
20, wait, what was it, 26 and
It's
20,
multiplied to
this
Eight.
way, like stretched out versus like squished rather than,
It also squished it, yeah. But it's not, we're not just talking about the sine x, we're talking about the x on the bottom as well. So that's causes the difference, making the difference. All right, so 26, when you see 26, we just divide that up. We use the principle of logarithms, or limits rather, limit x over x,
goes one, right?
1, the limit of sine x over x,
one. I thought you had to substitute like, cause like sine x over x would equal one, but x over x is 0, so then it would just be one, but.
because you have to simplify before you substitute.
Okay.
Well, anything
What
divided
number
by
was that?
itself is one, right? Unless
Except
it's
0,
net is undefined, it's not.
0 is indeterminate, yeah.
Okay.
Limit x approaches 0, this one here, we're just gonna divide both the top and bottom. By x. I'll multiply the top and the bottom by 1 over x. The limit of 3 is
Uh,
3.
3. The limit of sine 4x is, over x is
4.
4. And the limit of sine 3x over x is 3. What happens to the 3's? So my limit is 4.
Hmm.
That was for number.
29.
28.
How do you do 29? Show, use a graph to show that the limit does exist.
Put it on the graph.
Hmm,
okay.
very
I think I have.
insightful.
But really, number 29, you could do it by substitution. If well, no, you can't do it with substitution because you get 0 in the denominator.
Yeah.
Could you do, no,
So
you
here's
have
the,
to do number 59.
so here's your graph.
It's 57.
So you didn't have to do 59?
No.
Okay.
You have to do 35, you said?
Yes, I ended up doing all of them, so. But,
I'll go back here in a second. You do this.
Check all the algebra.
Okay.
So that's what your graph should look like
which number?
for
29.
number
29.
29. Alright, last year we talked about if the numerator exponent is bigger than the denominator exponent, Alright, we don't have a oblique asymptote. We figured that out by dividing the denominator and the numerator.
Okay.
Alright, we get x plus one, so I have a x plus one here. Okay? And then I have zeros at negative 2 and 2. So get closer to the asymptote, get closer to the asymptote.
I had the one line right.
I also use my y-intercept. My y-intercept here would be 4, so it goes through 4. I don't have this line quite high enough. It should be up here someplace. So here, using this graph, and you see at 1, there is no limit here, because as I go from the right-hand side, we go to negative infinity. As I go to the right-hand side, I go to positive infinity. So there's no limit. Alright, any other questions?
59, even though typically no enough to
59?
yeah, well, I don't know if we were just like, we hadn't covered it yet, but,
No, we didn't talk about the sandwich theorem.
okay.
We're probably not going to either.
Okay, can we do 53 and 57
Is that
or
part of the
just
homework?
50?
It was
No,
Wait.
it wasn't.
59 every other odd, but I accidentally did all the odds, so I
Okay.
ended up like, I desperately weren't supposed to do it, so.
Can we do 57 and 53 or just
We have a
57?
list there.
57. Piecewise function between 0 and 1, we're graphing the square root of 1 minus x squared. So if you put 0 in, what do I get?
You would get, oh wait, put it in there. Okay, you get 1.
1. And if I put 1 in there, what do I get?
You get 0.
So there's that piece of the graph. If I go for between 1 and 2, I get 1. So that's going to be here. And if I get x equals 2, I get 2. I'm supposed to go from 1 to 2. I'm sorry.
Wait, that was 1 to 3.
Number 57.
Yeah, that's 1 to 3. 1, 2.
Oh, I put the dot in the wrong place then. So there we go. Alright, so the first thing it says, at what point C in the domain does f of f, does the limit x, as x approaches C, f of x exist? So where does the limit exist? Where do I have a limit? Or let's do it this way, where do I not have a limit?
At 1.
At 1?
At 2.
Isn't there a limit?
Okay, not really at 2 because I only have one side. I don't have two sides.
Okay.
So it does not exist at 1, does not exist at 0, and it does not exist at 2. So where does it exist? Well, it exists between 0 and 1 and 1 and 2. So that's where I do have a limit.
Okay.
Okay? The letter C says, at what point C does only the left-hand limit exist?
0, 1, 1,
At
2.
2.
At 2. The only place where the left-hand limit exists would be at 2, and where else?
1.
At
2.
1.
Oh yeah, sorry.
Because the left-hand limit does exist at 1, so 1 and 2.
Wait.
At what point C does only the left-hand limit exist? Okay, so we have to change that thought process. Only the left-hand limit exists. So where does only a left-hand limit exist?
2.
At 2. Because at 1 I have a left-hand limit and a right-hand limit. At 1. Everybody agree?
Mm-hmm.
at 2 is the only place where I have a left-hand limit, so that's the answer to letter C. Letter D, at what point C does only the right-hand limit exist?
0.
At 0.
Okay.
So that's what they wanted you to do to number 57.
Okay. So then, on number 55.
Number 55, remember the sign graph.
The limit would be,
There's your sine on the left-hand side,
uh-huh,
and here's your
cosine.
cosine on the right-hand side.
Uh-huh.
So again, where does I have a limit?
Uh-huh. So
From negative 2 pi
to 0,
to 0,
and then 0 to 2 pi.
then from 0 to 2 pi.
So then we're only the left hand would be at 2 pi,
Correct? And the right-hand limit will only be at
at negative.
negative 2 pi.
Okay.
All right, any other questions?
How do you do, like, how do you figure out the 45 or 48 ones?
All right, so it says match the function with the table. So at number 45, all right, where, if I simplify number 40, let's simplify number 45. Okay, x squared plus x minus 2, that is the same thing as x plus 2 times x minus 1 over x minus 1, correct?
Mm-hmm.
All right, with x minus 1 cancel out. All right, so what is my limit as I approach? Let's see where they're showing here are 0.7s. So what's my limit as I approach 1 there?
2.
What's that?
Like, close to, oh. It's 3.
3. So look at your tables. Which one, as I get closer to 1, is getting closer to 3?
C.
6.
Yeah.
Correct. All right, if I look at number 46, x squared minus x minus 2 over x minus 1. Well, if I simplify this, that's x minus 2 over x minus 1, and the x minus 1 cancels out. What's my limit as I approach 1 here?
-1.
-1. So when I look at the table, which one, as I get closer to 1, getting closer to -1?
A. Oh, wait, no. D.
Which one?
A and D.
Did I do that one right? X squared minus x minus 2. I put 1, I get -1.
I think it'd be -2 and then x plus 1.
What's that?
Would it be x minus 2 and x plus 1?
Oh, yeah, you're right. I knew I did something wrong. Okay. All right, so this one here, nothing cancels out, so I have no limit at 1. So which one shows me that I have no limit at 1?
Ready? Or
No, it's not.
D and B?
What's that?
Is it D and B?
D and B. All right, so which one would it be? Letter B, I'm positive on the right side, negative on the left side. And letter D, I'm negative on the right side, positive on the left side. So one way to check, say, okay, let's go with something higher than 1. Put 2 in. put 2 in, I get
0.
0. Do I have anything that's getting closer to 0 as I get closer to 2? All right. If you want to test it out again, let's put 3 in. That's 3. That's 1 times 4 over 2. 2. So am I getting bigger or smaller?
Then, bigger.
Am I? Let's put 4 in. 2 times 5 is 10 divided by 3.
Probably getting smaller.
Getting smaller.
So it is B.
So it is B.
Okay.
So you have to play around with it a little bit that way to be able to tell those.
Can you assume that 48 would be A because the rest have an error at 1 and the denominator in 48 is different than all the other ones? And all the other ones are the same.
You could, yes. Yep. Any other questions? We good? All right, pass this forward, please.
You want the next homework too, or no?
No, just last night. All right, so let's look at limits dealing with infinity. Limits dealing with infinity. I'm going to change your quiz to no. No, I won't change it to tomorrow. I'm going to have it take home quiz. All right. So
Is that just the same thing as range? I mean,
Sort of.
What?
I guess so, yeah.
just having it. Yeah, change.
horizontal asymptotes. Horizontal asymptote says that the limit as x approaches infinity, f of x equals b, and the limit as x approaches negative infinity of f of x equals b. So we're going to use our basic function, f of x equals 1 over x. And that's what my function looks like. And if I notice, if I go toward infinity, my graph is getting closer and closer to 0. And as I get closer and I go negative infinity, my graph is getting closer and closer to 0. So my horizontal asymptotes will come as I have limits as I approach infinity being the same. Okay? And again, we talked about that in pre-calculus, that if my highest degree term in my numerator and my denominator are the same, that simplifies to 1, which my horizontal asymptote would be at 1. If my denominator largest term is less than my numerator largest term, then it would be at 0. And if my numerator is higher than my denominator, then I don't have a horizontal asymptote, I have oblique. So take for instance, f of x equals 3x over x. My horizontal asymptote would be 3, y equals 3. If I have f of x equals 3x squared minus 5 over 2 minus 2x squared, my horizontal asymptote would be
None. Wait, you would
your highest degree exponent,
Oh, just those two, -3 halves?
negative 3 halves. Alright, if I had my f of x equals four x squared plus 5x minus 3 over 2x squared minus 5, my horizontal asymptote would be what, Connor?
Say again. 3 over 2. I mean, negative 3 over negative 2. Oh, that one.
Stay with us. Again, I take my highest degree terms, simplify them,
1 1/2, 1/2.
Alright.
I mean 2.
2. So therefore here I can say the limit as x approaches infinity of f of x would equal 2, this one, and the limit as x approaches negative infinity of f of x equals 2. Because my horizontal asymptote is going to give me the value of my limits as I approach the infinities. And I see that because my graph would usually be going like this toward my horizontal asymptotes. And I can't have two separate horizontal asymptotes. Now we talked about logistic, where we had asymptote here and asymptote here, and that's where we have two different horizontal asymptotes. But most of our graphs are going to have the same horizontal asymptote, according to what we have there. If I had f of x equals 3x plus 5 over x squared minus 9, my horizontal asymptote would be at 0 because I have 3 over x. Any form of 1 over x is horizontal asymptote at 0. So here I would have the limit as x approaches infinity of f of x equals 0, and the limit as x approaches negative infinity of f of x equals 0.
So if it was like 3x over x cubed, would
Same
it also
thing.
be 0?
Same thing, yep. Any form of 1 over x would be 0. Okay?
But the x's have to simplify to something over 0. I mean a constant over x.
Mm-hmm. Yes.
Sorry, I don't know why I said that.
Yep. Alright, then we have the vertical asymptote. So again, we look at f of x equals 1 over x. And we have this. And we notice that my vertical asymptotes, which my vertical asymptotes here, my right hand limit and my left hand limit are,
0. Oh,
if I go into 0,
Opposite.
Negative.
they're opposite at my vertical asymptotes. Okay? And where do I find vertical asymptotes usually? Denominator. Alright, so let's look at this. If I have f of x equals 3 over x squared minus 2. I'm sorry, let's do 4. Alright, when I look at this, my vertical asymptotes will be at
2 and negative 2.
2 and negative 2. My graph would look like this. I have a 0. Do I have a 0 anywhere?
No.
Alright. Do I have a y-intercept?
Yes.
If I put 0 in, I get negative 3/4, correct?
That's right.
So here I can write out my limits. The limit of f of x as x approaches infinity. 0. The limit of f of x as x approaches negative infinity, 0. Connie, with us? Alright, the limit of f of x as x approaches 2 from the positive side, infinity. The limit of f of x as x approaches 2 from the negative side, negative infinity. The limit of f of x as x approaches negative 2 from the positive side, negative infinity. And the limit of f of x as x approaches negative 2 from the negative side, infinity. So you notice what happens at every one of my asymptotes.
It's the opposite.
Limit switches around. Now, that doesn't necessarily happen when I have this, 1 over x squared, because I have a repeatable asymptote. Just like when we had even multiplicities of zeros, I don't switch. So anytime I have a repeatable multiplicity or a multiplicity of an asymptote, it's the same as I have a multiplicity of a 0. Remember, if I have an even multiplicity of a 0, it touches but does not cross, correct? Same thing with asymptote. If I have an even multiplicity of an asymptote, it does not cross. It stays on the same side. So if I'm going to infinity here, I'm going to infinity here. So, when we're dealing with f of x equals this here. Alright, so we're going to graph it. I have a 0 where?
0 at, well, 3.
No, zeros come from the numerator.
Wait,
2.
what?
At 2, zeros come from the numerator. Right? Are you with us? Come on, stay with us. At 2, I have an asymptote at
Well, like a vertical or something?
vertical asymptote,
That would be -3.
-3. And I have a horizontal asymptote at,
0, no, 1?
no, you're right, 0, because this is x squared,
Oh, okay.
and this is x, that's 1 over x. So I have a horizontal asymptote at 0, but I will cross at the 2. Alright, so what happens? We come down here, but what happens here,
It flips up.
I stay the same, so therefore,
Oh, is that because it was even?
correct,
Okay.
the limit as x approaches infinity is
Infinity?
0 because it comes back down and stays along the asymptote, and the limit as it approaches negative infinity is
That is 0.
0, and the limit as x approaches 3 or negative 3 from the positive side, negative infinity, and the limit as x approaches negative 3 from the negative side, negative infinity. So we're writing all our asymptotes using limits. Alright? As a vertical asymptote, we always have 2 limits. One from the right hand side, one from the left hand side. All my horizontal asymptotes, I have 2 limits. One going to infinity, one going to negative infinity. Okay? So what I want you to try to do tonight, on page 76, Do numbers 1 through 33 every other odd. 1 through 33 every other odd. Page 76, 1 through 33 every other odd. And you're going to do the take-home quiz.
Okay.
You can use your book.